In this video, we look at structures and bonding. The first example is molecular covalent. Here's some examples of molecular covalent compounds. We have water, ammonia, carbon dioxide, and methane. Next is giant covalent or giant molecular. Here we have the structure of diamond. This is a giant covalent structure. If you compare the molecular covalent here and the giant covalent, you can see that molecular covalent form individual molecules, whereas giant covalent structures, you don't really have an individual molecule. It's just a giant structure of atoms all joined by covalent bonds. The last example is the Ionic lattice, which is here. This is sodium chloride, and it's an ionic compound, and they form what we call an ionic lattice. Let's take a closer look at molecular covalent substances. They have strong covalent bonds between atoms, but they have weak intermolecular forces between the molecules. So here's an example. This is carbon dioxide. These two lines here represent a double covalent bond. So these bonds, these covalent bonds between the atoms of carbon and oxygen, these are strong and require a lot of energy to break. However, here we have carbon dioxide molecules. The intermolecular forces between the molecules are weak and easy to break. So let's have a look at the physical properties of molecular covalent substances. They have low boiling and melting points. They are mostly liquids and gases at room temperature. For example, water is a liquid, oxygen is a gas, carbon dioxide is a gas at room temperature. This is because of the weak intermolecular forces between the molecules. They have low solubility in water. However, some polar molecules such as NH3, ammonia, are soluble in water. And they have low electrical conductivity. That means they don't conduct electricity very well. Next are the giant covalent structures. These have strong covalent bonds between atoms. Here's the example we looked at earlier. This is diamond. Diamond has strong covalent bonds between the carbon atoms. Here's another example. This is silicon dioxide. And again, between the silicon and the oxygen atoms, there are these strong covalent bonds. So let's look at the physical properties of giant molecular substances. They have very high boiling and melting points because of the strong covalent bonds between atoms. They are very hard for the same reason, because of the strong covalent bonds between the atoms. They have low electrical conductivity, and they are insoluble in water. Next is the ionic lattice. So here we have the ionic lattice for sodium chloride. You can see that we have Na plus sodium ions and Cl negative chloride ions. The ions are held in place by strong electrostatic attractions between oppositely charged ions. Each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. The physical properties of ionic substances. They have high melting and boiling points because of strong electrostatic attraction between oppositely charged ions. They are brittle because of the repulsion between ions of the same charge. They are soluble in polar solvents such as water. They do not conduct electricity when solid. However, they are good electrical conductors when molten or dissolved because ions are free to move.